Hello and welcome to Space, here from the Observatory of Geneva, home to experts in exoplanets, the name given to planets outside our solar system. So far, they've managed to find 3,559 of them, but they believe there could be literally billions of them across the Milky Way. Let's find out more. The first exoplanet to be discovered looks rather like this. What's known as a hot Jupiter, a giant gas planet orbiting close to its star. That discovery, made by University of Geneva Professor Michel Mayor in 1995, kick-started a revolution in astronomy. A revolution that's taken us from one confirmed exoplanet to thousands.
It's amazing. It's incredible. That in 20-odd years we've gone from a dream, are there planets around other stars, to the discovery of such a large number.
Over the past 2 decades, research has focused on hunting smaller planets like our own.
Nowadays, people are excited about more specific things. Finding habitable planets, rocky planets like Earth, at a distance from their star, that means liquid water can exist there.
The vast majority of exoplanets can't be observed directly because they're far too dim to see compared to the bright stars they orbit. So scientists have developed 2 key techniques to detect these distant objects, as exoplanet expert David Ehrenreich explains.
So we're going to do a little simulation to explain how we detect planets. So I've got 2 snowballs. The small one will serve as a giant planet, like Jupiter, a gas giant, and this is its star, a bit smaller than our Sun. The method that we developed here, because we can't observe the planet directly, consists of observing the movement of the star as it's affected by the planet moving around it, and that gives us the mass of the planet. Then, in certain situations, we're lucky and we see the planet pass in front of the star, and that's what we call a transit, a tiny eclipse. And that shows us the size of the planet, and that's what we're going to measure from space with the Cheops mission. Sometimes the planet and the star get away.
This is Cheops, an ESA satellite currently being built and due for launch next year. In space, it will be able to measure the radii of exoplanets with unprecedented precision. That data will then be paired with ground observations from ESO's VLT telescope in Chile to seek out rocky planets like Earth. And in spring this year, the VLT's exoplanet hunting abilities will be boosted by a brand new instrument called Espresso.
Welcome to the clean room at the Observatory of Geneva, which is home at the moment to the Espresso spectrograph. Espresso is everything you can see here, with the instrument inside this vacuum chamber. The light comes through here, through this device. It's collected and sent into a tiny optical fibre the width of a human hair. This optical fibre takes the light here up to the spectrograph. And there we take the light and we spread it out into its different colours. That's what a spectrograph does, in order to analyse the spectrum and determine the speed of the stars. It's really the best spectrograph we can make today. It's the Ferrari of spectrographs, and it's with that we'll search for habitable Earth-like planets, we hope.
It's thanks to innovations like Cheops and Espresso that the field of exoplanet research can expect to accelerate its rate of discovery even further. So will we find another planet like our own, rocky with liquid water and a breathable atmosphere? It's an epic scientific challenge, but British astrophysicist Carol Haswell is optimistic.
The dip that would be caused by the Earth transiting across the Sun is 1/100th of 1%. So if you think about that, we need to measure the brightness of a star to a stability of 1/100th of 1% over a time span of 3 years. So that's not a trivial thing to do. And I think it's going to turn out that habitable planets with liquid water on the surface that we could potentially walk around on are going to turn out to be plentiful.
Hunting those Earth-like exoplanets demands extreme precision, but the scientific rewards on offer mean the pioneers are now joined by scores of new researchers.
That number didn't get there by itself. It means that a lot of people are working in this field. An old dream of humanity is now a skyrocketing sector of science.
From hot Jupiters to frozen ice planets, it's projected our Milky Way is home to over 1 billion exoplanets. The hunt is on to find them. Away from exoplanets now, and to the first episode in our new mini-series, Legends of Space. Throughout 2017, we're going to be looking back at some of the greatest moments in space exploration, from Sputnik to Rosetta. And this month, we look back to January 2005, when Europe's Huygens probe made history.
The 14th of January 2005, Huygens landed by parachute on the surface of Titan. So the Huygens landing is the furthest landing ever achieved in the solar system. The signal arrived 45 minutes late, so there was quite a few moments of stress. But when the data on the channel that was working came down, when we could see the first images, it was really magic. When I first saw the panorama the next day, I said, well, it's the Côte d'Azur. It looks like the Côte d'Azur. But the ingredients are quite different, because it's minus 180 degrees on the surface. So the hills are ice, the liquid is hydrocarbons of methane, and perhaps methane and ethane mixed together. And now Huygens will be forever on the surface of Titan. And maybe one day a new mission will go and say bonjour to Huygens. But I don't think it will happen soon.
That's all from us here at the Observatory of Geneva. You can keep up to date with other news from the universe on our space blog on Euronews.com.